Algebra 1 Lesson 90, we are adding and subtracting rational expressions. Now we've looked at multiplying and dividing these rational expressions just a couple lessons ago, but now we're adding and subtracting. Now with this, remember your fraction rules, because those same fraction rules are what you're going to use to add and subtract your rational expressions, those that have those variables in the denominator. So we have to have a common denominator, of course, and when we do add or subtract, that denominator that we have in common doesn't change. So for example here, 2x squared over 20x plus 3x squared over 20x. Now we can add these up because we have common denominators, so we're going to have a common denominator of 20x. And then since they are like terms, we can add them up and get 5x squared. And we can simplify this a little bit to say 5 goes into 24 times, and then we have an x left on the numerator. So we can simplify it like that. In the second one, similar thing is going to happen. We get 10y because those are like terms. And because we have common denominators, we were able to add, and we have 4y squared on the new denominator. And we can simplify that to 5 over 2y. Okay, so simply get those common denominators and add or subtract. Now it gets a little bit trickier when we have polynomials, because especially with subtraction, we have to distribute a little bit. So I'm going to put it over this common denominator of a plus 2, and I have to warn you once again, we cannot simplify these a's, okay, or these a's because they are not factors. Currently they are connected to other things with addition and subtraction. But we can say that in the numerator we have 3a minus 2 minus the quantity a minus 6. And remember, we have to make sure to subtract the entire thing so that we have 3a minus 2 minus a and then a positive 6 because we distribute that negative to both the a and the negative 6. That's going to be over a plus 2. We simplify with like terms, so 3a minus a is 2a. And negative 2 plus 6 is positive 4. And right now, let's try and factor to see if there's anything more to simplify. And we see that 2 times a plus 2 gives me my numerator over a plus 2, meaning now we have two factors that are in common that I can simplify. So my answer is actually just 2. Okay, we're going to try a similar thing for the second one here. Okay, remember we're subtracting. We do have common denominators, which is good. We have 5 plus g, and I'm going to go ahead and distribute this negative 1 to everything. So I have 21 plus 3g minus 1 and then plus g. Minus a negative g is a plus g. And I combine like terms to get 20 plus 4g over 5g, 5 plus g. I can factor out a little bit, so we have a factor of 4, so 5 plus g over 5 plus g. Those can cancel out, and we have an answer of just 4. So it's nice when we do have those common denominators, okay, because we can just go ahead and add these together. And that's what I'm going to do up top here as well. I'm going to add together the numerators and get z to the third, and then negative 10z squared and 4z squared are common terms, so we have minus 6z squared over, now I'm going to factor the denominator right now, okay, and it looks like this is a common quadratic where I need to multiply to get negative 18 and add to get negative 3, and that's going to be z minus 6 times z plus 3, and now I'm going to factor the numerator and take out a z squared. So z squared times z minus 6 over z minus 6 times z plus 3. Meaning that z minus 6 is a common factor I have that I can simplify and get that I have z squared over z plus 3. Now I have an actual variable in the denominator, which means I need to exclude a certain value that makes the denominator 0. So z cannot equal negative 3. We have to exclude that value. Okay, and similar one on the right side here. I'm going to do it very quickly. I combine my terms and get 2k squared minus 6k over this k squared plus 5k minus 24. I factor both, so I'm going to factor out a 2k in the numerator to have k minus 3. And in the denominator, I'm going to do k plus 8 times 2k minus 3. The k minus 3's can cancel out, so I have 2k over k plus 8. Nothing more to simplify here, so I just have to exclude k as negative 8. All right. Now, if we do not have common denominators, so let's say we go back to normal fractions like 2/3 plus 3/5, and I want common denominators. That means I have to get a least common multiple, and in this case, it's 15. And I need to get both denominators there, so I need to multiply by something over itself. So in the first case, 5 over 5, so I can get a denominator of 15, now a numerator of 10. And on the second one, a 3 over 3, so I can get 9 over 15 to give my answer of 19 over 15. Same rules apply with our rational expressions. We need to get common denominators. And sometimes we have to think about what is that least common multiple. We can think about the numbers, in this case, 6 and 2. Well, 6 would be the least common multiple of those. And between the variables, h and h squared is the least common multiple with the variables. So we need to get these both to 6h squared. And in the first case, I really just need to multiply by h over h. So I get 2h to the 5th. And in the second case, I really just need to multiply by 3 over 3, so I get 12h squared. So in this first case, I can now add them together. They're not like terms, so I just have to leave them as 2h to the 5th plus 12h squared over 6h squared. And we can factor a little bit and simplify. I'm going to factor out a 2h squared to get h to the 3rd plus 6 over 6h squared. So the h squares are factors that can simplify, and the 2 and the 6 can simplify. So my answer is h to the 3rd plus 6 over 3. Now in the second one, I am looking for a common denominator of 10x to the 3rd. Okay, that is the least common multiple. So I multiply, in this case, by 2 over 2. So I get 2 over 10 x to the 3rd plus multiply by x squared over x squared. So I get 4x to the 3rd over 10x cubed. All right. And we can combine them together to get 2 plus 4x to the 3rd, not common terms there, over 10x to the 3rd. And I can factor just a little bit to factor out 2, to have 1 plus 2x to the 3rd over 10x to the 3rd. So the 2 and the 10 can simplify, and I have, I'll write it right here, 1 plus 2x to the 3rd over 5x to the 3rd. So we have to exclude x as 0. Okay? Whenever I see that variable in the denominator, make sure you exclude it. All right. Now, if you have a polynomial that is not a like term, we can still do this. We still have to find that common denominator, though. And the easiest way to start doing that is by factoring. So the first one can't be factored. We still have x plus 3 over x minus 4 minus 2 over x minus 4 times x plus 5, which means that really this first fraction is just missing a factor of x plus 5 in the denominator. And that's what I'm going to multiply by, x plus 5 over x plus 5. So I multiply those out and I get x plus 5 times x plus 3, and then I minus 2 over my factor of x plus 5 times x minus 4. Now try to, I'm sure right now you really want to simplify the x plus 5 and x plus 5, but try not to do that because right now it's still connected to this minus 2 with subtraction, and so it can't be done. Okay. Now we could see if multiplying it out and simplifying with a factor would work, and so we do that. We can do our rainbows and smiley faces here and combine together, and so we get x squared plus 8x, and then we have plus 15 minus 2 is plus 13 over x plus 5 times x minus 4. And I could try to factor that numerator, but it's not going to work. So we actually leave it as is, but we have to exclude this first x plus 5 could make the denominator 0, so x cannot equal negative 5. And the second, x minus 4, could also make it 0, so x cannot equal 4. All right? Lots of steps there, but factoring will be your friend in this case. So I'll do just another example here. In this first case, this can factor to x minus or x plus 9 times x minus 1. So it looks like this first fraction is missing a factor of x plus 9. All right, x plus 9. So we can simplify here and say that I have x plus 9 times x plus 3 minus the whole quantity of x plus 5. That's all over x plus 9 times x minus 1. Now I can try and work with that numerator to see if I can factor it again a different way in order to simplify anything. So let's try. And I'll need to multiply this out first. So I get x squared plus 12x plus 27 minus this x and minus 5. Okay? And that's all over x plus 9 times x minus 1, which means that my numerator is x squared plus 11x and plus 22. And it looks like with my factors of 22, 1 and 22 won't work, 2 and 11 won't work. So it looks like I cannot factor that, so I just put it over the x plus 9 times x minus 1, and I exclude some factors. X cannot be negative 9. And x cannot be 1, because both of those would make those individual factors 0, which would make the entire denominator 0. So we have to exclude them. All right, now if we have opposite denominators, how do we get them to be common denominators? Okay, well, there's a couple different ways to go about this. If we think that they are truly opposite, okay, here we have a positive v and a negative 4, here we have a positive 4 and negative v, then I could go ahead and multiply. Let's try by negative 1 over negative 1. So I get negative 8 over negative v and a positive 4, which is exactly what I have in the other one. Okay, I have a negative v and a positive 4, so I now do have common denominators. So I can add these together and get v minus 15 over negative v plus 4. So if you have opposite denominators, multiply by negative 1 to get those common denominators. Okay, and you can try that with this one here. All right, now I'll just show you a couple more word problems here that you can try. A plane flies 2,000 miles with a headwind and makes a return trip with a tailwind. Write and simplify an expression for the total time of the round trip, assuming the wind speed W remains constant and the plane averages 500 miles per hour. So in this case, what you are doing, headwind, of course, means you're flying into the wind, which makes you slower, which means your going rate, okay, is going to be a little bit slower, 500 minus that W, which means that the time it's going to take, we always do distance divided by rate in order to find time. So we end up with 2,000 over 500 minus W, okay, and the returning is going to be 2,000 over 500 plus W, which means that we need to add them together. And so I'll show you this work right here, and it's a lot of work, but you can definitely work through it, hopefully. Okay, here, let me erase a little bit. So in this case, you need to add some things together that don't have common denominators. So we need to multiply by a polynomial over a polynomial. And you end up with this expression once you multiply it all out. And so you can add those together and get a simplified version, like you can see right here. And so this expression right here is where the wind speed represents the time of the round trip. Okay, a lot of work there, but you can definitely take some time to read through all of this. And you can try the same thing with this one right here. Okay, try your best here to follow these same steps in order to figure this one out. All right, well, I hope this helped for your homework and for studying.